Good evening and welcome to the Marion Minor Cook Athenaeum. My name is Isabel Lilias and I'm one of the AF Fellows this year. In the fall of 2015, I took a Jane Austen literature course. This is a complete coincidence, which I still consider to be one of the best classes I've ever taken. And around this time, 2 years ago, we were reading Northanger Abbey. And one of my favorite statements about the power of literature is a quote from this book, which reads, "It is only a novel, only some work in which the greatest powers of the mind are displayed, in which the most thorough knowledge of human nature, the happiest delineation of its varieties, the liveliest effusions of wit and humor are conveyed to the world in the best chosen language." Now, while I'm biased to the novel because I am a literature major, there is an abundance of ways and languages to understand and examine human nature and the way of the world. Yes, maybe the combination of artificial intelligence, Jane Austen, and the law may not roll off the tongue or click in the mind as easily as bread and butter or wine and cheese, but they are all ways in which we perceive our environment, process the structures that govern it, and inform our actions and choices. For what's not to say that technology and law don't also display the mind's greatest powers, or the thorough knowledge humanity has to offer in all its complexity and variety. Our speaker tonight will address the question of whether artificial intelligence can augment our understanding of literature and change the practice of law. An expert in machine learning and natural language processing, Apoorv Agarwal is dedicated to understanding and improving how humans and machines benefit from working together. His work, which focuses on sentiment analysis, relation extraction, text summarization, and automated Q&A, has received more than 1,000 citations across the international research community. Apoorv Agarwal received the IBM PDH Fellowship Award in recognition of his work as first author on 2 separate patents for IBM's Watson. He received his MS and PhD in computer science from Columbia University and received the Andrew P. Casorso Memorial Award for outstanding performance in teaching. He has published more than 30 academic papers in machine learning and natural language processing. In 2014, he was awarded a grant from the National Science Foundation's Innovation Corps program, which allowed him to lay the foundation for founding his company, TextIQ. Beyond academia, Apoorv Agarwal has been cited by American Banker, Wired, Popular Science, and Science Magazine. With TextIQ, he aspires to harness and channel the complementary strengths of human and machines towards solving high-stakes enterprise data problems. Among other novels, his research focused on the work of C.S. Lewis and Jane Austen. He is the co-creator of the TED Talk Artificial Intelligence, a performance explaining artificial intelligence to a non-technical audience through movement. As always, I must remind you that audio and visual recording are strictly prohibited. Please silence and put away your mobile devices at this time. And please join me in welcoming Mr. Agarwal to the Athenaeum.
Well, thank you so much for the kind introduction. I'm really very excited to be at this venue. And since morning, I've had an opportunity to interact with a lot of students from the 5 schools, and I've really enjoyed my time here so far. Just to continue, start from an introduction, I joined Columbia for my PhD in 2009. And we decided to do some research on literature. So we used artificial intelligence systems to extract sort of social networks of characters and their interactions from literature. And later in 2014, we got a grant from the National Science Foundation to start this company, where clearly there were a lot of things that we had learned and done research on, which we could now take outside of the context of literature and use it on a real world problem. That problem happens to be in the field of law. And of course, it was a extremely interesting journey, and I've always kind of wanted to kind of find time to articulate like how that happened, when that happened, and this talk kind of gave me an opportunity to articulate this journey and story. So thanks a lot for this opportunity, and I'm very excited to share kind of the story of how we started some research around literature, which no one could ever imagine being commercialized, but then we were able to create an application that's actually now is even helping the government find sensitive information in data sets. So a couple of goals that I'd like to achieve through this talk. One of them, and I've been hearing this question a lot today, but also a couple of your alums and Jay is in fact still at CMC. Now Jay and Ben, they work at TextIQ, and they've been curious about whether or not they should learn computer science, if so, how much, why. So I think one of the goals I'd love to achieve today is really to encourage people not so much do a computer science major, but I think we live in a world where the amount of devices that are smart or that are intelligent is only going to increase. And I think it's very important to understand that, hey, if I'm texting my refrigerator asking if there are enough tomatoes or not, I think it's important to understand how this process is working. And for people who won't understand, they will live with kind of this perpetual anxiety of, hey, are these machines now going to take over the world or not? So I think especially in this world, it's rather important to understand how these computers function, and everything is logical, and it's really very controlled. And this kind of bleeds into the second goal that I want to achieve through this talk, which is remove some of the anxiety around AI taking over the world or bringing the world to war. And there are a lot of, I think, celebrities in AI who've rather recently put out kind of statements saying that this is inevitable, but I really don't believe it's ever going to happen. So I'd love to present my thought process and kind of an argument of why we're not only far, far away from it if it were to happen, but I actually believe a lot of work needs to be done even for us to get to a point where we can say this will or will not happen. So these are kind of the couple of goals I'd love to achieve through this talk. And I thought a lot about how to structure. That's a lot of things to kind of get through to tell you about this journey, tell you about AI and something about literature as well as law, what we do at TextIQ. At the same time, project outwards and maybe say a bit about the future of AI and such. So in thinking about how I wanted to structure, I thought I'll structure it around the purposes of AI. What are the purposes that AI is serving in our society right now? So I think one of the most obvious purpose that it's serving is that of automation. So we are taking pretty much kind of all the monotonous and mundane jobs that don't really require creativity and automating them using artificial intelligence algorithms. So that's where our company plays a role. We're not replacing humans, but we are augmenting humans, their capabilities in a way where they can achieve what they want to achieve in a more efficient and effective way. So one of the purpose of AI, which is obvious and clear, is automation, and that would be most of my talk, where I'll take you through, give you a sense of what can be automated today, what cannot be, followed by what we do at TextIQ, followed by connection to literature, how it all kind of got started. The second purpose of AI, I feel, is kind of self-realization. And self-realization may not even be the right phrase to use here, but let me try and explain what I mean by this. So I was working on Watson once, after it won kind of the Jeopardy game show. We were trying to adapt Watson to the medical domain. Sure, it was a great kind of marketing stint, but now we wanted Watson to do something interesting or something useful. So what we were trying to do with Watson was give it like a set of symptoms for a patient and have Watson come up with a diagnosis. So if the patient has a low-grade fever, a headache, blah, 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 what does Watson believe the diagnosis to be? Right? So that's what we were trying to adapt Watson to. And in doing so, we actually ended up hiring real doctors. And I remember in our lab was pretty open, and in our lab all the researchers would kind of sit around, kind of the doctors, and we'll bring up a question and then ask the doctors to think out loud. What is kind of the thought process that they're following to come up with the answer? And very much like that example, the process of building AI systems is actually a very introspective activity. And we're perpetually curious and thinking about, hey, how do the human mind works in solving a problem? And once we understand that, then we try to replicate that thought process through a machine learning pipeline or a process. So it actually, I would argue that AI, one of the purposes it's serving is actually helping us, even if it's through a reward function, but it's actually helping us think harder about, hey, how do our minds work? How do we solve problems? And also where we kind of came from, how did the world evolve? So this would be kind of the second and the shorter part of my talk. And finally, I think one of the other purposes that AI is serving is that of accelerating creativity. And unfortunately, this is a whole beast in itself. This is also a topic that I haven't really deeply thought about. So I won't really be, go into this, but I'm certainly seeing instances, around me where I see mathematicians and, artists using AI to kind of, sort of accelerate the creative process. Have AI produce, a set of, hypotheses, a set of structures, and then the human comes in and chooses, what works for them. So I won't really get into this, but I think, this is also yet another purpose that AI is serving. And this is a list that, I kind of just came up with. So I think in the Q&A session or later, I'd actually love to get your feedback and would love to hear from you if you think there are other purposes that AI is serving. So starting with automation, I think just as a few examples, self-driving cars. I don't know if you've seen them in LA. I have not seen them in New York, thankfully. But they're inevitable. Very soon we'll be driven around by self-driving cars. Virtual assistant. So I actually have an assistant who named Amy, who schedules all my meetings. So I literally just go in, I CC Amy, and the person I'm trying to schedule a meeting with doesn't even know this is a robot. And Amy talks in natural language. She has access to my calendar. She says, I'm free at these times. Which time works for you? If the person says, hey, this time doesn't work for me, she comes back with suggestions. One thing I find absolutely amazing about Amy that I think humans have a hard time doing is time zone translations. And I didn't dislike scheduling meetings so much, but if I had to now schedule a meeting in India or London or other time zones, it was just a nightmare. So I literally just tell Amy, hey, I'm in this time zone, and the person is in this other time zone, figure it out, and she does it really well. So this is one example of automation. And I don't know if you've come across brain-computer interfaces, but there are certainly kind of interfaces now where we've studied the brain enough to understand that if a person thinks about something, maybe the color red, or they want to do a movement with the hand, we figure out what are the patterns of neurons that get fired in the brain, and then we can translate these patterns into actually a physical movement. So now there are devices out there they're not totally, I guess, commercial, but this woman on the chair, she can't really, move her hand, but now she's just thinking that she wants to have water, and this robotic arm has the bottle, and it actually brings the bottle to her for her to have water. So that's yet another, in fact, a very noble, automation that we can do using AI. So that's all, good. And I think, like I mentioned earlier, very much we live in a world where absolutely, I think it's debatable how quickly, but absolutely whatever can be automated will be automated. There's absolutely kind of no question about it. The big question is what can be automated, and not in 50 years, not in 20 years, not in 10 years, but sort of what can be automated today. And there was a very good study done by McKinsey. I don't love the title. The title is Where Machines Can Replace Humans. I like to think more as machines, augmenting the humans. But this was a great study that kind of studied a lot of verticals in the industry, so finance and I don't know, oil and energy and certain other kind of job functions. And they tried to analyze, so the example I'll show here is finance and insurance. So they found these two broad categories of job descriptions, that people do, or job functions that people do in the finance and insurance industry. So one job function people do has to do with managing other people or stakeholder interactions, or applying kind of some expertise. The other set of job functions that people do is around data collection and data processing. So they took all of these job functions and then they calculated, hey, how much time collectively do people spend on these job functions? Turns out over 50% of the time is actually spent collecting data and processing data. So not management, not stakeholder interactions. Actually, large part of this vertical is spent on just collecting data and processing data. Then they also presented some statistics around what they thought could be automated in each of these job functions. So the upshot here is, actually there are a couple of upshots. One upshot is nowhere in the future we'll have robotic managers. Robots won't be managing humans anytime soon, and only about 15% of people who are in leadership roles or who are doing kind of stakeholder interactions, only 15% of everything they do can be automated. So that's not a lot. However, over 50% of everything people who are doing data collection and processing do, that can be replaced by machines. So this was kind of an interesting statistic, and if you were to make career choices based on this report, you certainly kind of want to manage other humans or want to do stakeholder interactions and not do a lot of data collection and processing, because all of that will be, or a lot of that will be automated. But it's the thing to note here is even that's not 100%. It's not that all of data collection and all of data processing will soon be done by machines. And that kind of brings me to a point that very much we live in a world where it's a great time for humans and machines to collaborate together towards a kind of a not a common goal. Machines don't really have a goal, but towards our goals. And going back, I know for a fact, like 10 years ago, when I was working on sentiment analysis or working on some other NLP problems as a technologist, I wanted to build machines that could. It was a kind of hurt our pride to know that, hey, a human will be in the loop to run the machine. We kind of wanted to build machines that would just replace kind of a function, now that I've gained more and more kind of experience working on real-world problems, I'm able to appreciate kind of the role of a human in the loop. So I think technologists in general have come to accept this idea of having a human in the loop when they're running their AI systems. At the same time, I think non-technologists who don't study, let's say, artificial intelligence or computer science, they've also come to accept AI. And just given if we're trusting our cars to drive us around, I think we better trust I don't know, our virtual assistants to schedule our meetings. That's less deadly after all, or maybe not. But there's certainly, I think, an acceptance from both people who build the AI systems and the consumers of AI systems to actually accept one another and kind of work together to achieve kind of the end goal. And I'm going to tell you a few frameworks. I don't expect anyone to really recognize these frameworks. These are very it's a machine learning kind of parlance, but in case you're interested, there are these frameworks that we can now use to bridge this gap or have machines and humans work together. So one such framework or paradigm, it's called active learning. Another one is called reinforcement learning. It's used a lot in kind of game theoretic settings. So when Google built AlphaGo, that beat humans at the game Go, it used a lot of reinforcement learning, and also interactive machine learning, where humans and kind of machines can work together to cluster things or do other kinds of things. And this is, I now want to give you kind of a sense of how powerful this is, especially how powerful this is in economic sense. It actually makes a big difference in the real world. So what we do at TextIQ, and I'll go more into it later, but one of the things we do is identify sensitive information. So I want to kind of give you a sense of how long it takes and what it takes to do the same job of finding sensitive information without machines and with machines. So what we've done at TextIQ, HCI stands for Human-Computer Interface, where kind of a non-technical person can interact with the machine, make sure the output kind of looks good, or provide it some feedback or training data, and now together they can work to find sensitive information in data sets. So this is these are real statistics on a real matter that we worked on. It was a big healthcare provider, and they had about 2 million documents to go through. And if it wasn't for technology, if they had they used their normal process, it would have taken them hundreds of humans and about 20 weeks to go through these 2 million documents. And now we've shown it multiple times that this process is actually pretty inaccurate, and they know for themselves that human mind is fallible, it gets tired, and humans do miss a lot of sensitive information. So on average, we've seen that humans are missing about 10% of sensitive information. And the cost to client, that's kind of the most remarkable kind of statistic here. People are actually paying to get this done per document. So people are paying about $2 a document. They're paying humans $2 to look at every single document. So if this client, they had 2 million documents, if they wanted to run their normal process, it actually would have costed them $4 million in just a matter of 20 weeks. That's kind of a big number. And 2 million is, it's not that big of a number. There certainly matters where people have many more documents, and the document size are only increasing. Fortunately for us, this client didn't really have 20 weeks. They did have the money to spend. 4 million, they would have spent the money, but fortunately for us, they just didn't have the time to spend 20 weeks. They had about 4 weeks because the court imposed deadlines on when these people can finish the job. So they were very stuck. We're a small startup, don't really have a lot of security certifications, but these guys were stuck. They had no other option but to try our technology. So that's how they kind of cut through and shortcutted their security clearance and all this process and actually ended up using our technology. But after doing that, they were very happy because we were able to get them the results in 2 weeks, which is about 10 times faster. They did their own sampling and looked at our results, didn't find any sensitive information that we had missed, so they were very comfortable turning over documents to the other side. And we were able to save them about $3 million in a matter of a month. So this client now is very happy with our technology and kind of continues to send us data sets in which it wants us to find sensitive information. But just to kind of contrast, so this second column is just humans, just search terms, and the third column is humans with machine. I mean, the value proposition or the value that the latter process provides is pretty clear. It has a faster turnaround time, it's more accurate, and it's much cheaper. So that's kind of the impact that this idea of humans and machines working together can have. They can have an impact. They are having an impact on real problems in the real world. So that's a good segue to what we do at TextIQ. So I've alluded to it a bit, but I'd love to tell you a few of the things that we do, and more importantly, the kind of machine that we are trying to build, and that will kind of lead me to talking about literature. So all the literature enthusiasts, it's coming, and I will spend some time on it. So at TextIQ, so there are a number of kind of legal and compliance disasters out in the world. Facebook, I think a few months ago, was fined over $100 million by the European Union around some data policy privacy concerns. Earlier this year, Aetna had to pay a huge fine of $1 billion to Humana because this merger didn't go through. And there are several examples of these hundreds of million or billion-dollar fines that is really hurting the US economy and in general the economy at large. And the question is, what are companies doing today to kind of either mitigate the risk of these legal disasters and compliance disasters, or how are they dealing with it? So believe it or not, the status quo, even right now, is very much search terms and human bodies. And what people do is they take a bunch of search terms. So let's say someone's looking for, and I actually do have an example, so it'll become clear. But let's say someone's looking for a certain kind of sensitive information. They'll come up with a list of search terms, very much like the way you use Google search. Whatever comes back, they'll get humans to go through every single document that hits the search term. And just to give you a statistic, JP Morgan alone, a big financial institution in New York, has hired over 8,000 people since 2008 just looking for sensitive information in their data sets. So they've spent kind of a lot of time, a lot of money, a lot of resources doing this, and even then we know humans make mistakes. It's not a very effective process. Now just imagine you happen to be this person who's looking at emails of some employee who works at JP Morgan, right? This email is literally pulled out of context. You don't know who the people are. You don't know what the conversation is around. You don't know what the context is. And so it's very hard for humans to look at documents that are pulled out of context and kind of make any sense out of it. And that's what makes this process very risky. That's why humans are missing a lot of sensitive information that they should be catching. And before I give you a very specific example of how this technique kind of falls short and where we come in, let me just make a definition. And this is one kind of sensitive information that we look for in our clients' data sets. It's attorney-client privilege, and the definition of this kind of sensitive information is, at least part of the definition, is these are communications between attorneys and clients regarding legal advice. So let's say you're an engineer at Google and you're working on a patent application. What you're doing is you're communicating constantly with the in-house lawyers who work at Google or represent Google, and you're putting all your ideas of what's novel about this patent, what's the innovation, why is it different. All of this information actually exists in emails between people. This is highly sensitive. Imagine for Apple. Apple's whole business is reliant on this element of surprise that, hey, the world doesn't know what we're coming out with next. And it's a very business-centric problem. They cannot put out a document out in the world that kind of tells everyone what the product roadmap looks like. So actually people put in a lot of sensitive information in their emails while communicating with attorneys. So by law, these set of communications or these set of documents are protected. So if Google gets into a litigation, let's say with Oracle, they don't need to turn over privileged documents to Oracle. They will have to turn over everything else that's relevant to the litigation, but they don't need to turn over privileged documents, which usually have a lot of sensitive information. This is one type of sensitive information that we find for our clients right now. Just to be able to kind of visualize how the current process looks like, the current process is to come up with a list of search terms. So because these are communications between attorneys and clients, what they would do is get the names of all the attorneys that are, that work at, let's say, at Google, and they'll come up with other generic words like attorney, legal, or privilege, and they'll search for all of these terms in a large set of documents. And whichever document hits any of the search term, now there's a human sitting in front of a computer, in fact hundreds of humans sitting in front of computers, going through every single document and saying whether or not this is privileged, whether or not this is sensitive. Right? So that's kind of the current process. And there are two obvious problems with this process. One problem is that search terms, they catch too much junk. So let's say there's this email, hey Mary, how was your weekend? Even if Mary is an attorney, this email is not going to be privileged, except, I don't know if you've turned on this kind of disclaimer that people put in the end of their emails. This email is privileged and confidential, and so on. But a lot of people, they by default have this kind of footer, set in their emails, and whenever they send an email, it's automatically added to their email. So when you search for a word like privilege, this footer is pretty much in all of corporate email data set, and pretty much everything comes back. So search terms are highly over-inclusive. They catch a lot of junk that has nothing to do with sensitive information. So this is what makes the kind of process time-consuming and expensive, and this is why the client that I alluded to earlier, it would have taken them 20 weeks because there's just simply too many things to go through. But the bigger problem is that search terms are also what we call under-inclusive. They miss a lot of sensitive information which we want to catch. So here's an email. It's to Mike. It says, hey, heard back from John. He recommends we multiply the two prime. I made this up, two primes to generate the key. Now there's really all the words in this email are very general. You're not going to search for John in a corporate email data set. Everything will come back. It doesn't have the other obvious words like privilege, confidential. And so a search term will actually never hit on this email. But if John turns out to be John Powell, the attorney, then by definition, this email is actually privileged. And Google or whichever company, they can withhold it. They don't need to send it to the other party. So this is where search terms fall short. And this is what creates or makes the process rather risky, where people are in fact turning over confidential and privileged information to the other side all the time. And just to summarize, this is the status quo, and hopefully, hopefully I've got the point across that it's highly inefficient, it's expensive, and even after throwing however money you want to throw at it, it's still very risky. So just to give you a sense of what we do at TextIQ, or how we'd be able to catch this document, thinking about just the human thought process of why we would call this document privilege. I think first, if humans, we'd want to know, hey, who are Sarah and Mike at this company? We would like to know who is this John that's being mentioned in this email. We'd also like to know what's the relation between John and Sarah and John and Mike. And once we establish that, hey, in fact, John turns out to be John Powell, who's an attorney, and Sarah and Mike are clients of John, that's when we'll be able to conclude that, in fact, this is a privileged document that we should withhold. So at TextIQ, one of the things we do is, given these emails, we are actually automatically able to identify the organizational roles of people who are emailing one another. We are also able to automatically identify who John is. And think of it, if Sarah is emailing Mike, then intuitively, and mentioning John on a first name basis, intuitively, both Sarah and Mike know John. And if they know John, they would have communicated with John at some point. And if there are too many Johns in kind of their shared social network, we can use language and context to figure out exactly which John it is. So it goes far beyond search, where we need to bring in not just the linguistic analysis, but we also need to analyze kind of people, their roles, to figure out what's going on in this document. And then many times people don't even have a complete list of attorneys that work at their company. Believe it or not, this is true. We've now worked on several matters where people don't have a complete list of known attorneys. So one of the things we do for our clients is actually go fish for attorneys in their own company and find that, hey, this person is actually an attorney who maybe left 10 years ago, whatever, but was an attorney. And we find relationships between people, and we can tell how these relationships kind of change over time. So in terms of kind of the vision, the sort of machine learning platform that we're trying to build at TextIQ, it not only understands language, and it can understand many kinds of language. So our machines can work with about 130 different languages, but it also understands people to some extent. It understands roles of people within an organization. It can comment about the personalities of people. It also understand relationships between people. In fact, if this video is going live, we'll need to edit this part of the talk for sure. But a lot of our clients are very worried about one of the sensitive information that they care about are actually romantic relationships within an organization, believe it or not. Every single large organization, not every single, but a lot of them we worked with, there are always these embarrassing documents within corporate email data sets that they obviously never want the other party to discover, because then in litigation or in court, they can get an upper hand. So one of the things we now do is actually go in and find unknown romantic relationships between people. And the reason why we're kind of building this is because our world is, first it consists of people, their interactions and their relationships, and everything else fills in. Given a document, a standalone document, if we understand who's the author, who's the recipient, we understand what are the interests of the author, what is the background, what is the role. Given all this context, we'll actually understand the content of the document itself better. So this is kind of the main thesis that we're working with. And the thesis is that before we go in and understand a document, we kind of need to understand people and their interactions and their relationships. So that comes first. And once we understand how people are organized within an organization, we understand kind of how the organization functions. In fact, I would argue CEOs of large organizations, they have no idea how the company is working. You know, what are the departments doing, who's doing what, how is everything organized, how is it generating revenue. It's very hard as soon as companies grow over even 50 people. It's very hard for one person or a set of people to really understand how this organization is functioning. But given, you know, communications of people, you know, we're building machines that can actually understand people, their relationship, their roles, and kind of start to understand how is this company actually working or functioning. And once we understand that, then actually zooming into all kinds of sensitive information becomes much easier. So what we're trying to do is kind of build a platform that understands how the organization functions. And once we understand that, there are many, many different kinds of sensitive information that people care about. And we're building applications per, you know, type of sensitive information to help our clients find those in their corporate data set. And where sort of, you know, the motivation came from, believe it or not, it kind of germinated from this novel, that fat novel I carried for 1 year with me, trying to get through it, and didn't understand a word. There are just so many characters, so many, you know, such large kind of communities, so many social and complex interactions and relationships that it was really hard to follow. In fact, the only thing I think I remember from War and Peace is why Napoleon got his the number 666, and how we can do the 666 calculation, you know, given someone's name. So it was very frustrating to kind of get through War and Peace. And when my advisor got this grant, when I started my PhD, I was like, hey, if you want to build a system that understands characters, their interactions, that can figure out communities and social relationships, I'd really want to build something or run it on kind of War and Peace. Hopefully, you know, I'll understand it better after the machine summarizes War and Peace for me around characters and their interactions. So actually, that's where you know, this motivation to even start working on something that understands people and the relationships and interaction kind of germinated from. So this is the segue to literature, our research that we did, you know, around literature. And just to give you, rewind the clock and give you some background, we incorporated our company, TextIQ, in 2014. But a lot of the research that we do or used, we started doing in 2009. And we got this grant from the National Science Foundation, which was about studying how people create social and organization relationships. But the grant was in the context of Enron emails. So I don't know how many of us know about Enron, but this was a company that did a big fraud, accounting fraud, was shut down in early 2000. And after it went bankrupt, some part of their emails were released to the public, to researchers, to see if researchers can find, you know, how this company functioned, or how, if there are ways we can develop to detect these kind of frauds or these events automatically, so that, you know, California doesn't lose electricity. So we had to do this research in the context of Enron emails. However, there were two problems that we realized. One was we didn't have all the communications of Enron employees. We only had communications of few employees. So the data was inherently incomplete. And the second, that we really didn't have any ground truth. None of us worked at Enron. We had no idea what were the relationships between people. We had no idea how the organization functioned. So if we build a machine that made some predictions, we wouldn't know, and if, let's say, the prediction was bad, we wouldn't know if it was bad because of our methodology or because of the data set that we were using. This data set was incomplete, and also there was no ground truth we could compare our predictions with. And that's why we decided that, hey, let's build this machine using literature, and once we build something that in fact is useful or provides value, then we can spawn it on kind of a corporate email data set. So an author, of course, in a work of fiction, they introduce characters, build characters' personality, introduce other characters, and through interaction, build relationships. All of these things evolve over time, but it's a confined world, and it's a kind of a complete world. And so that helps us alleviate the first problem, which is it's not incomplete data, it's complete data. If our machines are in fact able to, the methodology is right, then we should be able to figure out or comment about the roles of characters in the novel accurately. And the other thing is, all of us have read Alice in Wonderland. We know what the queen's role was. We know what the rabbit's role was. So that's just general knowledge. So if our machine predicted, hey, the rabbit is the protagonist or the main character, clearly that's a wrong prediction, and we'd have to improve our methodology. We can't blame the bad prediction on the data anymore. So that was the charm, and that was the advantage of working with literary texts, because even though these are artificial worlds, these worlds are still complete, and we know how, what are the characters, we know what are the communities, we know what are the relationships, so we can compare our predictions with what we know. So with that kind of motivation, we kind of set out to try to summarize novels around characters and their interactions. But we spend a lot of time just thinking about interactions, like how do we define interactions, what kinds of interaction, do we want to differentiate between two people talking to each other versus two people having dinner versus two people running together. So there are all kinds of kind of categorical or ontological questions that came up, and we actually ended up spending a lot of time reading a lot of even psycholinguistic and that kind of literature to come up with a categorization for interactions. And we came up with two very high level, it was an ontology that we defined, but at the very high level there were two types of interactions that we came up with. These are rather obvious, but one kind of interaction is bidirectional. So in this picture you see two people, the clouds are their cognitive states, and one is person A, person B. So person A has person B in their cognitive state, and person B has person A in their cognitive state. So now we're having conversation. You're aware of me, and I'm aware of you. So this is kind of a bidirectional interaction. The other kind of interaction is one directional. Let's say I start talking about I don't know, Obama right now. So there's evidence that I have Obama in my cognitive state, but as much as I like, there is no evidence that Obama has him in my has me in his cognitive state. So that's kind of a one-directional relationship. And through a study on Alice in Wonderland, we actually were able to show that differentiating between these two types of interaction tells us a lot about the roles of characters. In fact, it also tells us about the status or the influence of characters in a story. So just to give you an example, we found that, hey, the queen was a person in power. Clearly, I mean, she was responsible, for Alice's execution. And we found that throughout the novel, a lot of people talked about the queen. They referred the queen in all kinds of different plots or events. But the queen interacted with a small set of people at the end. And in fact, the sets of people that talked about the queen was quite different from the set of people that the queen interacted with. And we found that, so this is a clear differentiation between, we use both unidirectional relationships, people talking about the queen, and mutual interactions where people, the queen is interacting with. So because we differentiated between these two kinds of interactions, we were able to notice this, and you can imagine, like, for example, a celebrity. Everyone talks about the celebrity, but the celebrities, they would interact with very few people, and this set of people would be quite different from the set of people that talk about them. So in corporate email, data sets, if you want to find people in a position of power or who's influential in a given team or in a given business unit, this observation actually helps us in identifying people whose title may be misleading, or title could be an engineer, but actually turns out that this engineer is very influential in this team. Literally everyone's kind of talking about them, but they have a very small set and different set of people they're interacting with. So differentiating between these two types of interaction actually helped us, allowed us to comment or find things that weren't even written anywhere. It was nowhere written that this was in fact the case, but we were able to infer knowledge which wasn't kind of memorialized in writing anywhere, which is very powerful. We are also able to find, and this is a matter of fact finding, but we get excited as computer scientists that we are able to find this automatically, that the story was being told from the perspective of Alice, and in fact she was the protagonist. So again, we had to make use of both the unidirectional and bidirectional relationships to infer this. And we also found that the role of the rabbit, so we were able to find the roles of characters in a story. We were able to find that the role of the rabbit was pretty much to move the story along. The rabbit was never in a position of power or influence. And in fact, if you study the props character theory, or there are other kind of character theories that say what are the kinds of roles that characters need to play to build a story, like a protagonist, antagonist, one of the characters that people often use, I don't know if that's the right technical term, but a flat character whose only role in the story is just to move the plots along, who really doesn't contribute much else, but allows the author to move kind of the plot along. And depending on time, I'd love to kind of tell you a funny story, but how much more time? Oh, really? All right. So we built a system that was able to extract a kind of social network. This wasn't, this is not the prettiest picture, but we took Jane Austen, pushed it through our system. And the characters here, the important characters are kind of in big circles. This is kind of the influence characters have. So Emma clearly was, the central character. Knightley, Harriet, and some of the other characters were also. There's a static view, but in a dynamic view, you could actually, look at exactly what the communications were about. You could summarize. You can find kind of the kinds of relationships different characters had. So there was an application of all of this on literary theories. Unfortunately, I don't have the time to get into this, so I'm going to skip over the literary theories that we validated. So here was the main conclusion. One of the theories said that as the settings go from rural to urban, the social networks change. In a rural setting, you would expect everyone knows everyone else, and it's a complete social network. In an urban setting, there are different kinds of social structures. But in a novel, for the author to make actually the novel digestible by the readers, they take out all the urban noise from the novel. So once they take out all the urban noise, the novel actually looks very much, in terms of social network, it starts to look very much like a novel in a rural setting. So that was one of the main conclusions. What else can we do? This is we can automate the Bechdel test. This is a test we automated on film screenplays. Never got around to do it on literature, but now that we have machines that can read through thousands of novels, we can see, hey, are there any patterns of kind of authors or time or genre where more novels pass the Bechdel test versus the other. We can also study props character theory and validate for ourselves, hey, is this a complete set of characters that go in to build a story, or are they more, are they less? So does this augment our understanding of literature? For sure, if I was in front of a computer science major crowd who know nothing about literature or as much as I do, my answer would have been yes, boldly yes. But in front of you guys, obviously experts in literature, I'm a bit hesitant to say yes. So I don't know what, my answer is, well, what do you think? Yeah. And the next part of the talk, which I can zip through in 5 minutes or not. Okay. Okay, I'll zip through it. It may not make any sense. It may not have made any sense, even if I had the time. But let's see. So the second kind of purpose of AI, I think, is kind of self-realization, and I believe none of this is going to happen. So Elon Musk said AI could lead a kind of Third World War. Stephen Hawking taking over kind of the mankind. Sam Harris argues that superintelligence is inevitable. It will just happen, and I really don't think it will happen. And think of these examples of automations or AI that we are building. We are building AI that can drive cars, and we will continue to improve this AI. But there is no matter how much we improve this AI that drives cars, it's not the case that suddenly this AI will become self-conscious or will start acknowledging other machines, as a species, and starting to realize that, hey, we're slaves to humans and retaliate or whatever, right? So the AI will continue to improve, but the kind of AI we're talking about, self-consciousness, is not even on the path of that improvement. No matter how much it improves, it's never going to be self-conscious, at least the kind of AI we're pursuing right now. And I think, and this is just a belief, it's a very kind of, it's just literally I'm sharing my beliefs with you. I don't have any citations, empirical, whatever, to validate. But I think if you were to build machines that are self-conscious and aware of one another, in some sense we need to simulate evolution. And to simulate evolution, of course, we'll need kind of very powerful hardware, because evolution, it's an exponential process. It's a very time-consuming process. So we need to come up with hardware that can do exponential number of calculations in linear time, because we don't want to simulate evolution that takes as long as our own evolution took. We want to simulate it in something that finishes in a month or in a year. So we'll absolutely need very good hardware to be able to simulate this evolution, and then we'll need to kind of come up with sort of some initial conditions of how we kickstart this evolution, and I think I don't know if you want to call it laws of nature, or some basic laws that would kind of govern this evolution. So I think the way to get to self-conscious machines, or machines that recognize one another, we need to simulate evolution. And these are the things. I'm sure we'll need more things, but at least we'll need all of these things to simulate evolution. So first of all, we're very, very far from it. Right now, quantum computing can hopefully get us there, but there are a lot of problems out there that are very hard. We just simply cannot solve, that require exponential calculation. So hopefully at some point we'll get to hardware where we can do exponential calculations, in linear time or constant time. But this is a very confined environment. It's not only confined by the hardware, because the simulation is running on a hardware, and unless the hardware is ether, which is, I can't imagine that to happen, it will be confined just by definition. Also, I think we will be absolutely in charge of what laws we use to have this evolution kind of go on, and it would be sort of bubble wrapped. It would be confined, and we will be more or less in control of how this world evolves. So for these reasons, I don't think so I argued that we need to simulate evolution to build machines that are self-conscious. And then the environment that we simulate in, it's a very controlled environment, and it's kind of hard to, think how, how these self-conscious machines that we built now are going to break out of the simulation, or, what's going to happen for them to kind of come into, our world and kind of retaliate or take over our world. And I think the reason why we'll, do this simulation is not because we want to build self-conscious machines. I think the motivation will come from this perpetual or constant conquest of understanding how we came into being, or what are the laws of nature that govern our world. And if we were ever able to or wanted to discover the laws that govern our world, the best way of validating what is that set of law, what is those set of initial conditions that led to the world we live in, is to simulate it and see if in fact that happens. And it's of course not going to be one world that we'll simulate. We'll end up simulating an exponential number of worlds with a different set of laws, and kind of see which of these worlds kind of evolve to start looking like the world we live in. And let's say in one of the simulation we find, hey, simulation number 729, whatever is, there are dinosaurs in this world that we created. Oh, it's kind of starting to look like our own world. There are very hard questions that we still need to answer. How will we actually detect if this simulation is leading to our world? Because there is this process of mutation, and it is unclear the sequence in which organisms appear in this world. It's going to be the same. They're going to look like humans or whatever. It's very unclear. And can these simulation lead to a species that are smarter than us? That's also unclear. I don't see why the species that we simulate is going to be smarter than us, but maybe. And if we as a species have this kind of urge to discover where we came from, and the way we discover this is through simulation, there is no reason not to believe that the simulation that we do will actually go through the same process, and they'd want to kind of discover themselves, and so they'll start, they'll get to a point, they'll make enough progress to get to a point where they simulate their own kind of evolution. And this, as you can see, is suddenly very quickly kind of becomes a recursive process. It's like a fractal. And now it's unclear when this recursion is actually going to stop, and even if it does stop, and we are able to discover the laws of nature that govern our world, it's unclear what happens when people are actually, or species are actually able to break out of these simulations. So there are a lot of I think questions and progress that need to be made for us to go from our world to kind of self-conscious machines. And I think for this reason I really don't believe AI is bringing the world to war or taking over the world anytime. So I managed to run out of time, but hopefully I've convinced you that computer science is cool. It does give us an opportunity to think about a lot of things other than just programming. It does allow us to connect with different kinds of fields and specializations, And so I would highly encourage all of you to at least get a basic understanding of computers, and hopefully I've at least to some extent helped remove the anxiety around AI taking the world. Thank you.
We now have time for a few questions. Please raise your hand if you have a question, and Isabel or I will come to you with the microphone.
Thank you so much for coming. I wanted to ask about your opinion on gendering personal assistants. So Alexa, Siri, and Amy are all gendered as female and presented consciously to our users as being female. I want to ask your opinion on, first of all, does not seem as necessary, perhaps, and like your opinion on sort of the implications that might have or changes in that area.
Sure, yeah, no, that's a great question. And in fact, the company that built Amy X.AI, they also have, male version. In fact, my advisor, he uses Siri, but I think he has the male Siri. So for all of these agents, maybe it was an afterthought, but people are, trying to kind of also produce, male versions, all of these assistants, and let humans decide which. Now, unfortunately, when someone did a study of how many people use a female assistant versus a male, it did turn out that even given the choice, most of the people were using, female assistants. So I think that just goes back to, this unfortunate gender bias, in society and community, where I guess we associate certain kinds of roles with gender. I won't know how else to answer this question.
Thank you so much for your talk. So I was wondering if you've heard of Ray Kurzweil and his super optimistic predictions for AI, and if so, what did you think of them?
I've been living under a rock. Running a company is very hard, so unfortunately I haven't. But I don't know if there's time. Maybe we can take this offline.
Thanks for coming. I wanted to ask, we've seen a lot of high-profile individuals talk about how AI is going to take over the world. I found your argument to be very convincing, so my anxiety is suppressed. Thank you very much for that. Where do you think the main divergence is between you and some of the other high-profile individuals in the AI space on that argument?
That's a excellent question. I think the divergence, or I think one of the major assumptions they're making is that, hey, AI has improved so much in 10 years, and imagine in the next 10 years how much it's going to improve. So it will go from being intelligent to being super intelligent. And now once it's super intelligent, hey, look, it can do things better than humans, which, by the way, it's doing right now. But these things are very specific. They can only do very specific things better than humans. But it's not that they can, no matter how much progress they make in driving cars better, they're not going to become self-conscious. So I think for super intelligent machines, or for machines to really generate or create their own things, we need to simulate evolution. No matter how much progress we make in the kind of AI we're pursuing right now, I don't think that kind of super intelligence can be achieved. So I would say that's kind of the point of divergence. I think the divergence is coming from the set of assumptions that we kind of believe in or are working with.
Hello. I just had a question about how computer programmers, what their opinions and perspectives, how those are incorporated into the algorithms, and if, from a computer science perspective, if those have checks and balances, especially when having these future predictions, and yeah, just your opinions and thoughts on that, if there are regulations in place, and if so, what do those look like? If not, how should they look?
Sure, yeah. So if I followed your question correctly, there is this need, and in fact an urgent need, to regulate some part of AI. and especially the part of AI that now is driving, robots or driving cars, which are actually a matter of, life and death. So the government they have a lot of work to do because the technology is ready to go, but the regulations and laws are not really there yet. So there is, in fact, a lot of work. But interestingly, this work is not coming out of computer science world. It's coming out of policy. So there are a lot of policymakers in DC right now who are, working night and day to come up with bills to kind of regulate AI and especially kind of the autonomous vehicle kind of AI. Most of the boundaries and checks computer scientists would put is just to make sure the system doesn't crash. So they're not very interesting, I think, to a larger audience. Yeah.
Thank you. Hi. I was interested in asking about whether for finding human relationships, was it like you would give a set of like different novels or stories and tell them like this name refers to the protagonist of each story, and then have the computer find like the common ground between those different protagonists? Or was it the other way around, where you like worked with one story and you edited the parameters until it like finally returned the right person? Right.
So we kind of knew the ground truth. We knew, who the protagonists are in, different stories. So we would run the novel, through our machine, and it would make prediction, and then we would validate out of, let's say, 600 novels, how many times did it get the protagonist right. So we would just use that to kind of compare the result, and then we'd of course have a training kind of data set which we'll give to the machine to kind of learn from. So when it's training itself, it would look at a complete set of novels. It would still, of course, read one novel after the other, but it'll kind of summarize and learn from kind of the complete data set to figure out how to predict who the protagonist is.
Hi, thank you so much for your talk. I noticed in the map of relationships with Emma that there are a few people on the side, like Shakespeare, who weren't characters, that they were just mentioned. I was wondering how good your programming is at discovering who is actually a character and who is not, or if they're good at catching that.
Mm-hmm. Yeah, that's a great question. And we didn't do this. So clearly, obviously our machines are not perfect. They made mistakes, and maybe Shakespeare was just mentioned, but because it was a name of a person that the machine detected, it thought that it's a character in the story, and that's why it appears on the map. I'm sure we can figure out ways of eliminating kind of these characters, because these characters are not really going to interact with other characters in the story. So characters that are just being mentioned or being talked about but don't really play a role in the story, maybe we can label them as external characters, but that's something we didn't do in our research.
Hi, thank you so much for your talk. I was wondering how you arrived at the conclusion that to make self-realized machines, we need to simulate evolution. I was a little confused by that.
Again, this is very much kind of a work in progress, and so I didn't get around to kind of talking about this, but obviously all the things I mentioned, one implication is there is no reason for us to believe that we're not in a simulation, and we're of course self-conscious, and that's kind of the reason why I believe that for us to, because consciousness is a very complex I think operation, and I don't know how we can just create it without following kind of a process of evolution from cells that are very simple cells that are not aware of another, but then through kind of a process of evolution, more complex organisms come into being that have a brain, that have consciousness, and they, that are aware of kind of other such organisms. So it's, I don't know, more or less a weak argument. It's just a belief at this point. But that's why I think for us to get to self-conscious machines, we need to simulate evolution.
Unfortunately, that's all the time we have this evening. Please join me in once again thanking our speaker.